Hello. Okay, so we have done up until how you represent a vector. Now we need our protractor and our compass for the next work, but I want to show you this work in class, how to do it. So because you can't see what I do with my protractor and compass, I'm not going to do this example now. I'm going to go on with the work, but you'll see I said you can do voluntarily question 1 and 2. It's not that difficult. You can try it. Please try it. And then but we will do it together in class as well. Then we have discussed last year what is, and this year, what is a resultant vector. The definition there: resultant vector is the vector sum of two or more vectors that is a single vector that has the same effect as two or more vectors together. Now we can add vectors together in different ways, or we can get the resultant of a vector in different ways. If they are in the same plane, meaning back and forth, left and right, up and down, something like that, then we can just add and subtract them. And this is examples from last year's work. Two men pull on a rope. One exerts a force of 200 Newton due east. That's just a fancy way of saying east. And another one, 700 Newtons due east. What is the resultant force? So we have the rope there, and someone pulls it with 500, and the other one 700. Because they're in the same direction, we're just going to say the resultant is 500 plus 700, and that gives you 1,200 Newtons due east or east. Okay, then a boy walks from the front to the back of a moving bus. Okay, so there's my bus, and the boy walks from the front to the back, and he walks 10 meters, and that happens while the bus is moving 70 meters. And they ask what is the resultant displacement relative to the ground. Now, because they're in opposite directions, we're going to subtract them. Now, to the right is bigger than to the left, so I'm going to choose to the right to be positive. And then my resultant force will be 70 plus minus 10, 1 negative 10, because it's in the negative direction, because I chose to the right to be positive, and that gives you 60 meters, and that will be to the right or forward or east or whatever. Okay, then we get the head to tail method, and we use this method when forces act successively to each other. It means first this happens, then this happens, then this happens. So let's say this is Mr. Van Zel stands there. So first he walks to the EGD class, Masuna's class. Then he walks to the Pavilion's tuck shop. Then he walks to the start of the athletics. And then he walks to the rugby poles. Okay, so this, then, and then, and then, and then. So you can see the arrows follow each other. Then your resultant force will be from your starting position to your end. That will be your resultant. So your resultant is the one vector that goes from the original, the starting position, until the final point. Okay, and then it just says make a rough sketch, and then you have your scale, and then you draw your vectors. Okay, now the next work you'll see there's most of the time there's a graphical solution, and then there's a calculation. Okay, I'm just going to do the calculation now. I'm going to explain the graphical because some of your homework does ask for the graphical, but I'm going to do this on the board with you in class because I need my protractor and my compass. But I'm going to quickly show it to you now, just on the right hand side, and you can try to do it on your own at home. So it says there a girl walks 100 meters west from A to B, and then 50 meters north from B to C. What is her resultant displacement? So she walks west 100 meters and then 50 meters north. So her resultant displacement will be there from the start to the finish. Okay, so when you have to do this graphically, you'll use a scale, and your scale will be something like 1 centimeter is 10 meters. So then this will be 10 centimeters, and this will be 5 centimeters. So you'll start here, and you'll draw a line that is 10 centimeters long, and then you'll draw a line that is 5 centimeters, and then you'll measure your resultant displacement. Or we can do this with a calculation. So I'm just going to show this again. So this is 100, and that is 50. So your resultant will be from there to there. Now, because this is a 90-degree angle, we can use Pythagoras to calculate the resultant displacement. So when you do that, you get it to be 111.80 meters. So that is the size of the resultant displacement. Now we also need the direction because it's a vector. Now the direction you always take either from your 0 degree line, so all the way to there, or we can just take this angle and we can take it from the horizontal. I'm going to explain that in a moment. Okay, so let's quickly just get theta. Let's just get that angle there. Okay, we see we have opposite and we see we have adjacent. So we have opposite over adjacent, and that gives you tan. So you're going to use your tan or whatever you call it. So that's 50 over 100. And you get theta. And remember, there is a second function tan or shift tan or whatever you call it in class. And that gives you 26.565. Now we don't round off the yet. That's not our final answer. So you can write this down because we need to put those things together, the size and the direction, in two different ways. You can either say, R is 111.8 meters at 26.6 degrees. Now remember, angles we round off to 1 decimal. Or, that angle there, but then you must say from where that is. So you're going to say that is from the horizontal. So you're going to say that from horizontal. So that is the angle there from the horizontal. Or we can take it from our 0 degree line all the way there. So you can say R is 111.8 meters at, and then we need it from the 0 degree line. So we know from there to there is 270. So then we're just going to add that 26.6 degrees. So it's going to be 296.6 degrees. Okay. Now the next one, number 2, it's a bit more difficult. I'm going to do that one with you in class. Then we can also use the parallelogram method. Now we use this method when we have vectors that act simultaneously on a point. Simultaneously means at the same time. Okay, so this is the example that I said, the river. So you swim in a river and the current takes you whatever. So you can watch that video. I'm going to explain all of this here at the bottom. Now again, we can do this either graphically or with a calculation. The graphic we're going to do in class. So I'm going to do the calculation. They say a swimmer crossing a 40 meter wide river is carried 30 meters downstream by the current. By construction, so that's graphical, or calculation, determine his resultant displacement from his starting point when he reaches the opposite bank. Okay, picture, drawing, always. So there's my river. The river, they tell us, I think it's 40 meters wide, yes. So the river is 40 meters wide, and the current takes you 30 meters downstream. Okay, so while you're swimming this way, the current takes you downstream, so you're going to end somewhere there. So you will end somewhere there. Why? Because while you're swimming there, the current takes you down 30 meters. So you can see here they have the same starting point. It's not like the hit-to-tail method that first this happens, then this happens. They have the same starting point. So the parallelogram method. But we know with the parallelogram that the sides of the parallelogram must be parallel to each other, and thus they will be the same size or the same length. So we can basically take this 40 meters up here. So this we can put there again. That is also 40. And we can take this 30 meters and we can put it there. There's 30. Okay. So here we now have two triangles with right angles, because it's straight down and 40. It's not always going to be right angles, but in this instance it is. So we can either use or work in this triangle, or we can use that triangle. Now I'm going to use the top one here. I'm going to use that triangle there. So I have a 90-degree angle there, and I want the diagonal there. So I'm going to use Pythagoras. So r squared is 30 squared plus 40 squared, and r is thus 50 meters. Then I want that angle there. So again, I have the opposite and the adjacent, so that is tan. So the tan of theta will be 40 over 30, and you will get theta to be 53.13 degrees. Okay, so now we need to put them together. So we're going to say, I'm just going to write here, R is thus 50 meters at, and I'm going to take it here, so we can either do it from the 0 degree line, so then it will be 53, that's a 5 by the way, 53.1 degrees, or, so that will be from the 0 degree line, that will be the angle, or you can say that from the river. I'm feeling I'm writing this incorrectly, river bank. Anyway, why? Because that is from the river bank there. Alright, so that is the way to calculate it. Remember, you can only calculate it if there's a 90 degree angle. Okay, and then this one here I'm not going to do with you. Again, I need to do this with you in class. So now we're going to go over to homework. Your homework is 3, 4, 5, 9, 10, 11. And you can do 1 and 2. It will be good if you do it, but we will also do it together in class. The first 3 is the head to tail method, and the last 3 is the parallelogram. Just see here it says do it graphically, and here it says calculate. The graphically means you need to do a drawing, and calculate means you do a calculation. All right, good luck, and ask if you have any questions.